Hi guys, we're going to go over the resistor setup for the iPad charging circuit. So here we have a USB connector here and just into a breadboard. And so first we're going to start with two 49.9K resistors. And the first one is going to go from ground to data positive right here. Bloop. You have to make the sound, otherwise it doesn't connect right. And then next we're going to take another 49.9K resistor and we're going to go from ground to data negative. And then we're going to take a 43.2K resistor and we're going to go from the VCC to data positive. I don't know if you can see that very good right there, so we're just going to go ahead and do that. And then last we're going to take a 75K ohm resistor and we're going to go from VCC to ground, VCC to data negative. So we're going to do that right there. Now the only how this is going to get power is through VCC. That's going to be your power feed, so we can put just a red wire there. We can bring it out to 5 volts. And then of course on the ground side you just do the exact same thing. Right here on the ground rail. If you can see that, there's some stuff in the way here, but it's just on this same. That's on the same line as the ground. Just bring it out to 5-volt ground, and that's pretty much it. All right, we're going to measure the voltage coming out of the data lines for the USB. We have VCC, data minus, data plus, and ground for the standard USB connector. This is crowded, so what I did is I brought these lines over here to this 4-pin header here. So this pin header is exactly the same order as this guy here, so it's easier to put a meter on. So we have a standard 5-volt power supply. You can pick those up at Adafruit, and we have my 10-year-old laptop that I got from someone that's actually being useful. It's running this meter program that tells me different things. So first we're going to start that actually. This is the supply. It's at 5.4 volts, and that's going to the first pin there. If we jump over to the next pin, which is the data minus pin, we'll swing back over here to the screen, and you can see it's 2.885 volts. And then we can jump to the next pin there, which is data plus. And that is 2.155 volts. And then of course ground is ground. But that's the voltages that you should end up with when the circuit is assembled. Alright guys, this is my iPad here. This is an iPad 2. You can see the battery's at 64%. And so if I plug this guy in, we'll see if our circuit works here. Pardon the camera just for a minute. Bloop. And it's happy, and you can see that it is charging. And so with this on, I'm going to go ahead and flip this guy on here. So it's the iPad there, and it's running. You can see here, if I flip over here, it's about 9/10 of an amp. So it's about 1 amp. So it's not drawing the full 2 amps, but the iPad does recognize it as charging. So it is charging. So with that said, I'm going to leave this on here for a while, and we're going to see what the graph looks like as far as over time, and then we'll see the percentage. We'll check back in a little bit and get another shot of that. All right, folks, we are back, and it's been about 1 hour, and you'll notice that the percentage, the battery percentage now is at 68%. The iPad's been on the whole time. And although that didn't go up very fast, an hour we started at 64, so about 4%. Very, very slow, but this is not what I built this circuit for. If we pan over here, we can see the graph here, and the idea of this was to keep the iPad alive in the wall. So we're charging faster than we're discharging. That's the whole goal here. So it's not meant to be a quick charger or a fast charger or even a portable charger, but this is just something I built to keep an iPad that's permanently mounted in a wall charged if the customer keeps the screen on 100% of the time, which is pretty much never happen, but if it did, I would still be covered because it would still stay charged. Also wanted to just show this working on an iPhone 4 I have here. You can see the battery is at about 30%. I plug it in and it's happily charging. If we take a look over here, we're just about at the same current there. I think an iPhone can draw up to 1 amp. One more thing I wanted to show you is that what happens if we take all the resistors out. So there's the 4 resistors that we had in there, and it was charging just fine. And I just want 5 volts on the rail. So we have a meter hooked up here. We're right about at 5.4 volts, what we were before. And we have an iPad here, and we're at 58%. We are going to plug this guy in. And it's plugged in tight, and you did not hear the noise because it does absolutely nothing at all. So if you don't have the right voltages on the data plus and minus of the USB, it does not even recognize that anything is there. So that's why it's very important to get those values correct, because the iPad itself dictates how many amps, including 0, it pulls to charge the battery.